All right. Hi, I'm Joshua Kolden. Let me make some space here. All right, so I'm the architect on the framework for ETC. It's based on work I've done at my studio, Studio Pixis, over the last 6 or so years. And it was originally designed because we were working on cloud processes to augment our on-set real-time virtual production processes that we had developed in the mid-90s for films like Avatar. So those processes, the idea is that you need to do coordination with the cloud, but really you can even take the cloud out of the equation because the real core issue is that you need to coordinate between different entities, different production domains, different individual people, business units, departments, and so forth. So the way you can kind of break this down conceptually is if you look at a production as it ramps up, if you look at the lifetime of a production, it has multiple workflows even within a production itself, right? So you might start out with, say, a director, the guy here with his star on his t-shirt, and a cinematographer, and they're just going out and shooting footage, and you can throw that up on YouTube and make your own content. And that's one scale. Another version of that might be, even for a professional, high-end studio production, you might have a level of the production that's just the screenplay, just the screenwriter, producer, and so forth are working together to develop the content. So you can see this kind of scale transform over the lifetime of the production. As you start producing real assets on real sets, you start getting metadata that might be notes from production people. You might get raw files that need to get processed in some way to create, editorial files or review files. Then directors put out notes, and there's all kinds of different types of data, different media from different locations. And then you want to start coordinating with different organizations. So you have visual effects facility, editorial, or maybe they're not an organization that's different, but they're just a different physical computer that's in somebody else's office. So all of these things represent kind of this abstract, difficult to conceptualize network of interdependencies. And I'm going to define these for now in my talk as domains. And so we kind of put a little box around these different sections. And so you might think of a domain as being a physical location like on set, or the director's laptop, or an entire facility like the visual effects company or editorial or so forth. So the problem comes about when you start trying to coordinate information that's happening at each of these domains. Now, we have lots of mechanisms in place today for doing that, but all of them have a failing in some level. So, and there's you might be able to have some commonality by having a local, a physical storage place. So coordination in this example might be transcoding compute that's happening in the cloud and a visual effects facility and an editorial facility that are sharing the same storage in the cloud. But then how is that data getting in there? The director and on-set are still not actually actively participating in that cloud network. Maybe they're transmitting their data via hard drive or some other way that you don't have absolute definite control over during the process of doing the transport. So this kind of coordination problem gets very complex, and from that arises the need for a unique, universal way to identify everything. So there's a lot of pieces of the C4 framework, but I'm going to just be specifically talking about the asset identification here. So if we have an array raw file off of set, it might look like a file name, something like this. Now, we want to refer to this file in a way that's unambiguous, and it's the same for every single domain. It's when you refer to that file and you talk to somebody over the phone about that file, or you write notes about that file, anything that has to do with this file, you want to be sure that it doesn't get associated with a different file, or people don't understand what file you're actually talking about. For example, if I gave somebody this actual file name, that may not mean anything because there's no real human readable information in the file name itself. And where is it? I don't know where it is. I don't know if I have it. I don't know if it's somewhere else. I don't know who in what other organization has it. So systems that exist today for addressing this universal identification problem are things like naming, establishing a unified naming convention so that you have coordination between different organizations, different departments, different people. URLs, like you have in your web browser, URLs and URIs. GUIDs, what are called globally unique identifiers. Turns out that you actually don't want every single ID to be unique, but I'll get back to that. And UMIDs, which was developed, published by SMPTE quite some time ago. Each of these systems have weaknesses in terms of creating the goal of a unified, addressable, absolutely unambiguous, absolutely authoritative identification of an asset. So like Guillaume was talking about doing SHA hashes, we've actually, as Eric was saying, because of performance reasons, SHA 512 actually performs faster than SHA 256, so we upgraded to the SHA 512 ID system, hashing system. And so that becomes this unique ID. So I'll show you what the advantages might be of thinking of terms of asset IDs instead of thinking in terms of like file names. So here's an example of just, an arbitrary file naming convention. So you might have something in a facility that says, okay, we always have shows, and underneath shows we have sequences and then shots and elements and what the resolution is. So in my mind, that really represents metadata, right? It's a file path, and it gives you an address and a location to find that asset. But it's also metadata. And we've kind of arbitrarily put it in this order because that was what was the CTO of the facility or the visual effects supervisor, whoever, like that naming convention or whatever. But the problem with file naming conventions like this is everybody has to agree in advance and participate in it. It's extremely prone to human error. And maybe this isn't really the pertinent metadata to your business use case. So it seems kind of arbitrary, like a production unit may not even care about a lot of this information, whereas a visual effects facility might want a lot more information than this. So binding metadata to the actual data is a little arbitrary. You kind of would prefer them be separate because different people have different sets of metadata. You want to have that flexibility. And conversely, you want to be able to look for all the different types of metadata. Like Guillaume was saying, we want to find things that different data silos might be containing, different software packages might be producing different types of metadata. We have to have a unique way of identifying it. So if we had that system, when you could still present it potentially like a file system, so you could access that file unequivocally, uniquely through a file naming convention, but you wouldn't necessarily have to know which of these metadata elements are required, and you wouldn't have to know what order they came in, because it could just basically be a database query, right? So in this example, the second path actually would index the exact same file. You get the exact same file back. And I've just changed the order in which those same pieces of metadata appear. But if you sit on an actual file system at a facility, you couldn't do that. You wouldn't find the file if you tried to change the order of those metadata pieces. So then you can actually, if you do have important relationships to an internal file system, you can always map that. You can say this asset is located in this specific location in our system, but that separates the location of the asset from the identity of the asset. So what this looks like is when you're trying to communicate between two or more independent domains, if you had file naming conventions, then that's like the first example here. You might you might end up with a file naming convention in one facility and a different one at the other facility. And so you can't really agree. If you call somebody up and say where the file is in your file system, doesn't mean anything to them. On top of that, it's not even really unique because somebody could easily just save over that file in that location, and it would be a different file now. So the location is not a good way to associate information with, associate an ID. So another idea is UMIDs or GUIDs or things like that. In this case, this is the first part and maybe the last part of a UMID. UMIDs always have the same data at the beginning, so there's a whole bunch of useless bytes in there that you're storing that have no value whatsoever other than to identify that this number is a SMPTE standard UMID number. Then it has about, I think, 16 bytes of unique data, but that unique data can be generated in a number of different ways, including things like using the MAC address of the computer and the date, for example. Now, there's a number of problems with that. First of all, it's not globally unique because it uses, somebody could easily change their MAC address in software-defined networking systems, and dates for that matter. So things could change. It also means that the same asset at two different locations could have this different UMID. So I'm talking about the same asset. We're both talking about the same asset, but we can't tell that we're talking about the same asset because I've identified it one way and you've identified it another way. So that aspect has a little bit of a quality of file naming conventions, except this is a number and I can't read it. So file naming conventions is actually better than this. Another aspect of the problem with this is that when you use things like your MAC address and date and information like that to create these unique identifiers, as a lot of these global identifiers do, you're actually leaking security information. You're leaking information about the computer that these numbers were generated on, perhaps the production, because you know the date and the address, in effect, the address of the computer. So that could potentially let you extrapolate. If you could say, well, I know that this is from a computer that's Industrial Light and Magic, at Industrial Light and Magic, and I know that this is the date, then that must be from the new Star Wars movie, right? So you can actually start extrapolating additional information that this, just in itself, the number itself, without having the access to the asset itself, just looking in the number, you might be able to start extracting some of that information. It also supports the idea of embedding certain amounts. The UMID supports the idea of embedding certain amounts of metadata. But that's kind of, again, a little bit arbitrary. They kind of decide in advance what metadata is important, what's not, and really you're still going to have to map that number to a proper database to get all the rest of the metadata that you really want. And it means, again, there's another way in which one domain might have the same file as another, but different UMIDs for that same asset. Whereas the C4 asset ID has exactly the same no matter where you are, right? It has this property that no matter who generates it, it will be the same ID for the same file. So I'll guarantee to be the same ID for the same file. It's guaranteed to be a different ID for a different file. It doesn't matter about it, the file name. It doesn't matter when the file was generated, where it was generated. It leaks no information about the computer that it was generated on. It contains no metadata that you could use to extrapolate information about the show. It's absolutely unambiguous. It's absolutely unique. You'll never find two files that are different that have the same number. So this becomes a kind of like a big address book. And anything that's in one of these IDs at that address is that asset. Now, you may have that asset in your physical facility, or you may not. But you can easily tell authoritatively that you do or don't, because if you know what all the asset IDs are of your facility, then you know what's in the set that you have and which are not. And like MD5s and hashes like that, you get the ability to deduplicate, you get the ability to do code signing so that you can sign the document and say that it was generated from this location based on private keys and so forth. And then once you have these authoritative numbers, you can actually start communicating between organizations and departments in a consistent way, and then internally those organizations can map these IDs to human meaningful things like the metadata, the file path, or other stuff. So an example use case might be to take an asset ID and associate it with metadata. So another aspect of the framework is to standardize everything to JSON as a data transmission and communication format. So here is a snippet of some JSON. And this is why it's recommended as opposed to something like XML or some of the other standards. So you can see here where it's just readable on both sides. You can read what the key is. You can read what the value is. Lots of web applications can communicate in this already, so there's no changes that have to be made. So in this case, for example, I can easily add an asset ID reference, and then I can say, okay, well, all of this information about this asset is, or all the information associated with that asset ID is here. So I could, for example, here's an IDER number. I could easily say, well, this is an asset that's associated with an IDER, or another ID system if you want to use, if you're still using UMID within an organization, for example, you can map the C4 asset ID to the UMID. So there's no need to really choose a favorite, ID system. You can use whatever ID system you like. This is just the unified mapping between everybody's ID system, regardless of what any individual or organization wants to use. You can also map relationships between things. Like in this case, this is a processing relationship where you say, okay, well, I have an input source. I'm going to run this command on that source, which might be like transcode via FFmpeg, and then it generates this result. Of course, before you've done it, you don't know what the result ID is, but once you've done it, you know what the ID is. And the interesting thing about that is that I could run that process in 2 different locations, and just by exchanging this one JSON piece of data, I would be able to confirm that I've done the process consistently with the way the other person did the process. And I have the same result without actually having to transfer the file. You can also do containment. So you could say have a folder or have a zip file or have any kind of relationship between things or containment of things. So you could say, well, I'm going to create a collection of DPXs which are actually derivative of are generated from, say, ARRI raw file. And so frame 1, frame 2, et cetera, are in this file. So you could easily have a description like this where you have, here's the asset ID of my DPXs folder, and then here's all of the actual assets that are contained within that folder. So even if you don't have them organized in this way in your system, having this document would show you how they are supposed to be organized. So this is how one normally would just identify something in the C4 asset ID, domain language. So you would take this file, we would generate an asset ID on it, and I can actually do that now just as a quick little demo to show you what we're doing here. So I'll go ahead and clear this out, but you can see if I echo the C4 asset ID of this particular file, there it is. Now, this goes into a little bit of why we don't use just the raw SHA-512, because if I do just the raw SHA-512 and put it into a base64 format, which is typical, then you'll see that it puts these dashes and underscores and equal signs in there. So now if I double click that, I'm only actually selecting a piece of that number. If I accidentally do that absentmindedly, I'm not actually going to capture the full ID. If I double click on the C4 asset ID on almost every single computer operating system, then I get the actual whole ID, right? So I won't easily make mistakes. Humans won't easily make mistakes failing to copy it properly. It also, this character set that we're using here, I'm going to turn off wrap here, make it a little bigger. So if I were to have to talk over the phone about this number, I might not need the whole number just to say, are we talking about, C42T, JM, XTT? Typically that's about as much as you might have to say human to human across a phone line to just confirm that that's the right number. That's a little bit harder for base64 numbers because it includes underscores and dashes. It also includes characters that are easy to confuse in certain fonts. So zeros, O's, I's, ones, things like that. So those numbers have been removed from this character set, so you won't accidentally run into a 0 and not know if it's a 0 or an O. So, and then unlike the asset IDs for UMID, which have it, you can identify that this is a UMID number because it has specific numbers at the beginning, 12 bytes of very specific numbers, but you have to be an expert in UMIDs to really keep those numbers in your head and know that every single time you look at that number and say, oh, that's a UMID. Whereas C4 has, the C4 asset ID just has C4 at the beginning of the number. So you can look at that and say, that's a C4 number. You don't have to know anything else about it. So now you know how to deal with that number. You know that it's going to be a SHA-512, and maybe you know, based on that, the relationship of it to a file or whatever in the context that you're using it. And so I have these two files here. If I were to just do, what is that, 94 and 95. So if I do 94 and then I do, the regular ID, and then 95, you'll see that they are, obviously going to be completely different each time that you do that. But if I were to do the same command at any location on that same file data, if you did it on your computer, this is the same number that you would come up with. So, whoops. Is there anything else there? Yeah, so there you go. And you can get more information. You can actually download that command line tool at ccc.io. If you have any questions, you can certainly email me, but I'll go ahead and open it up now if anybody has any questions or issues with it right now. Yeah, go ahead.
If it's an algorithm that I have locally, how can we be sure that it's not duplicating an algorithm that somebody else generated from a different file on their PC? Is there some kind of check that's going on, or is it just so many characters that we don't think it's going to be?
Right. We know that it's using the SHA-512 hashing algorithm, which is considered to be cryptographically secure, which means that it's a large enough number space that it is statistically improbable that anyone in our lifetimes will ever come up with two different assets that will have the same ID. So just the mathematical properties make that true. If you just change one bit in that file, it's a completely different asset ID. It's used in cryptography and communications and secure, processes all the time. So it's been well vetted as a secure algorithm. And when we're generating these things, we're relying on local standardized libraries to do it. So we're not re-implementing SHA-512, for example. We're using things from libraries that have been, tested and vetted by security professionals. So you won't. I'll buy you dinner or give you my car if you ever come into two different assets that have the same ID. You just won't. And yes, also on the flip side of that, the algorithm guarantees that the same bits of data will generate the same number for you as it would for me. Yes.
So MD5 performance in comparison is to.
Right, so I don't know the exact numbers. It is slower than MD5. MD5, though, is not considered cryptographically secure. There are collisions. You almost don't want it to be too fast in some senses, because the faster the algorithm is, the easier it is to just crawl through every single possible number. So what happens is there's this way, it's called a nonce, and the idea is that I could put a bit at the end of the file and rerun the hash, and put another bit at the end of the file and rerun the hash, and just keep doing that until I find a file that's different from my source file, but has the same hash as the source file. And you can do that with MD5.
Yeah, we're already experiencing serious problems just in trying to calculate MD5.
Oops, sorry.
So it does worry me that if you want to go to a SHA-512, when stuff's coming off the set, we're talking terabytes worth of data just trying to process it.
Right, so the idea is that we're working with hardware manufacturers and networking systems to try and create this as a standard there as well, so that these hashes are being generated on the fly when you're doing something like a file copy across file systems or networks. So it's kind of built into the cost of that. It's on 64-bit systems, it's very fast. It's one of the fastest algorithms there are. And like I said, the 512 algorithm is actually quite a bit faster than the SHA-256 algorithm. But every algorithm is slower than MD5, pretty much, and every good algorithm is. And so it's kind of a cost, it's kind of an expense that will have to be spent at some point anyway if you want to have this universal ID concept. And again, you don't have to use it constantly internally. You could choose to use MD5 or just assigned IDs internally like a file name. But when you want to interact with an external organization, you want to make sure that you're talking in those same terms. Any other questions?
I'll just add what he's saying. I mean, realistically, to his point about the file copying operations, unless you're talking about single file assets that is absolutely massive and slow storage and extremely fast storage, you're going to be able to outshaw your storage speed.
Your I/O, yeah.
Yeah, I think the barrier is just storage in general, which is ridiculously slow.
Right. But I mean, in our case, we're moving terabytes a day. Everything's being hashed, and we don't have any performance impact in that process.
Yeah, you're bound by something else than the hashing. And that's typically true. I don't know what issues you're running into, but
I think, again, you know, when you're dealing with Macs coming off of, whatever you want to call it, Macs coming off of cameras today, trying to move all that data, you're shooting terabytes per day.
So we're already talking to Sony and other camera manufacturers to be generating this ID on the fly. So it will come off of the camera with the file and the ID for the file, and you don't have to rerun that ID.
Yeah, and I've seen that as well. I'm seeing a lot of the Macs themselves as the data starting to be embedded straight into this, just another item as part of the asset stored.
Right. Just to keep in mind, you can't put any asset ID inside of the asset itself. Like Guillaume was talking about, you can put it in downstream assets, but you can't put it in itself. As soon as you put it in itself, it automatically changes the value of the file, and so now it's a different ID. So you can never do that.
You can calculate the SHA 512, right?
Say that again?
You can actually calculate as a, so basically, let's talk about this off.
Yeah. Okay. It actually does process the data in buckets. So you pass little blocks of, I can't remember, 64 bytes, I think, and it processes the 64 bytes and creates a hash of the 64 bytes and then processes that. So you can process while you're streaming, for example. You don't have to have access, random read and write access to the, or read access to the whole asset at once. All right? All right. Thank you.
And we do intend on releasing a white paper on that, hopefully later this week. So we have it all written up and documented already. We're just reviewing it to make sure and add some references to it. Next is going to be Chris Chen. Let's see if I can remember my own password. And he's going to be talking about string, which is basically how you create relationships between these assets.
See if we got it.
Chris?